This video gives a demo for weighted average cost of capital part 2. For weighted average cost of capital part 2, we basically covered how to calculate cost of equity. So we're going to use cost of equity to calculate the average cost of capital for the firm. And that is this part in this formula. And in part 1, we have already covered how to calculate E, which is the market value of equity, how to calculate D, and we're using here book value of the debt to proxy for that, and how to calculate RD, cost of debt, using 2 different methods, and also finally how to calculate the tax rate. So for part 2, we are using 2 different methods to calculate cost of equity. One is using dividend growth model. And for under dividend growth model, if the dividend is growing at a constant rate, then we can use the constant growth model. If the dividend is growing at a different rate, we can use multi-stage dividend growth model. And here, this is an example for 2-stage growth model. Actually, it can be 3-stage, 4-stage, and 5-stage. As long as you understand the idea here. The idea here is we always want to discount the future cash flows using the NPV idea to measure or to capture trying to estimate the current value of the firm, so which is P0. So as long as you know that, then you can simply use different dividend that you applied it to different growth rate. In this case, for D1, applied it to G1. And then finally, we're going to assume it is stabilized at some rate, which is G2. So then for capital asset pricing model, basically we want to know how to estimate beta first, and then how to estimate the market premium, how to obtain information for risk-free rate. So, and also an adjusted version of CAPM. So we want to apply the tax rate here for this risk-free rate. So now let's go ahead and look at the examples, the class examples. So first, calculating Merck dividend history. So all those following tests is related to finally calculating question 6 here. So question 6 here, we're gonna have a final number for the weighted average cost of capital for Merck. So putting all those information together, okay, we'll calculate net debt, tax rate, cost of debt, and here calculating the cost of equity using the dividend constant growth model, calculating cost of equity using the constant growth model based on equity payouts, and using CAPM to calculate the cost of equity, using tax-adjusted CAPM to calculate cost of equity. So we'll have 4 different estimates of weighted average cost of equity, cost of capital. And finally, perhaps we can just take an average of all 4 of them if they are not very different than each other. Okay, so let's go ahead and start. So for dividend growth rate, we're actually here trying to get the growth rate over a period of time. So now for the whole period, we're using here the last dividend divided by the initial dividend, raise it to the power of 4 times number of years. Now 4 is because the dividend is usually issued every quarter. And so we're trying to get the quarterly growth first, and then calculate the compounded growth rate for a whole year. So this formula is given. This is a way to calculate the, adjusting the growth rate based on the whole sample to a quarterly growth rate. So this is the average quarterly growth rate over the sample. So this formula will give us, based on the average quarterly growth rate, how to get the annualized average, annualized growth rate. There is a more simple way to calculate this. I'm gonna discuss it later. So which is use this formula, and then we can get this annual growth rate directly. So how to do this quarterly growth rate, annual growth rate in this case, I'll just copy the formula. Okay, and then I will just carefully select the sample period I want to cover. So the first two here, this two covers the whole period. And here I just want to use the last 5 years. So what is the last years? So that is 2012. So 1 year, 2 year, 3, 4, 5, and 6. Okay, let me check from 24. I should have four times 5, 20 numbers. So I have exactly 20 count here. So I should go from row 24 to row 43. So next I will choose this, since I'm including, oops, 24. Since I'm including 5 years only, so 4 times 5 should be 20. And this is correct. So I'm going to try to use this model directly. So equals. So B24. 40, 43 divided by B. Okay, that gives me the same result. If you derive this equation, you're going to easily see. So from here to here, I just plug in this GT to the formula here. So just change it to G. So here I'm plugging in this GT inside this formula here. So this is the original formula, like this equation here. And then I'm plugging in GT equals to dt divided by d0 raised to the power of 1 divided by 4 times n minus 1. So nothing special. This here will be just this formula. And then 1 minus 1 equals to 0. So it will just leave this item here. So I'm putting 4 times 1 divided by 4n. That will give me this final formula. So therefore, when I'm calculating this annual G in this way, actually it summarizes these two processes. So that's why when I'm using this formula directly, it will give me the same answer as this one. So I'm basically calculating this number in just one step. While for this, I have to calculate the quarterly growth rate first.